The next question of CodeChef Starters 115 is greedy LIS algorithm.
So in this question, we are given with two integers. One is n, another one is x. What we are supposed to do is, we are supposed to create a permutation of length n, whose longest increasing subsequence length minus the length of the given algorithm is exactly equal to x. Right?
Yeah.
The question says that we'll be given with two integers n and x. Our job is to create a permutation of size n. A permutation of size n means it should have all the numbers from 1 to n.
Yeah.
All the way till n. We should create such a permutation whose longest increasing subsequence length minus length of the given length of the longest increasing subsequence by the given algorithm is difference is x.
Yeah.
Right? They have given us an algorithm, and if you apply that algorithm to find length of the longest increasing subsequence, you will get some value. Let's say that value is b. Okay, and if you actually find out the length of the longest subsequence of that particular permutation, you get it as a. The difference between a and b should exactly be equal to x.
Yeah.
Right? If there are multiple such permutations with which this difference is achievable, then we can print any permutation.
Yeah.
That is the question. Looking at the constraints of the question, we are given t test cases, and t is in the range of 1 to 10 power 4.
Yeah.
We are given our n value, which is in the range of 1 to 2 to 10 power 5.
Yeah.
We are also given our x value, which is in the range of 0 to n. And it is also said that sum of n over all test cases will be less than or equal to 10 power, will be less than or equal to 2 into 10 power 5.
Yeah. 2 into 10.
Right? So we have to basically create an array of size n, which is a permutation of elements from 1 to n, such that the length of the longest increasing subsequence minus the length that we get from the algorithm that they have given us should be exactly equal to x.
Yeah.
Okay. That is the question, and the algorithm that they have given us is something like this. They have given us an algorithm which is int. Let's say algorithm name is algo, and in this we are given with an integer array int a, comma int n. They are asking us to find out longest increasing subsequence length using this algorithm, which will not give you the correct algorithm, which will not give you the correct longest increasing subsequence length, but still they are giving us this algorithm, and our job is to find out such a permutation where actual answer, that is actual longest increasing subsequence length, minus the answer given by this algorithm should be exactly equal to x.
Equal to x. Yeah.
Now, looking at this algorithm is, we have int count equal to 1, and then int last is equal to a of 1.
Yeah.
Now, they are starting a loop from I is equal to 2, I is equal to 2, I is less than n, I plus plus, I is less than or equal to n sort. And inside this loop, they are saying if your a of I, if it is greater than your last value, then they are updating, then they are considering this a of I to be part of the longest increasing subsequence. They are doing count plus plus and making this element to be the last element. So last is equal to a of I.
Yeah.
And at the end, this count is getting returned. Return count.
Yeah.
Now, this algorithm might not give us the longest increasing subsequence every single time, because if you take an example of this array, the array is 1, 4, 2, 3, and 5.
Yeah.
In this array, if we apply this algorithm, then this 1 becomes the first element. After that, this 4 becomes the next element. After that, this 5 becomes the next element. And the length of the longest increasing subsequence as part of this algorithm is 3.
Yeah.
But if we carefully look at the question or the example, then we can find out a different subsequence which is even better length or even greater length than 3, which is 1, 2, 3, and 5.
Yeah.
Right? So actual answer of the longest increasing subsequence is 4,
4.
but the value we are getting using this algorithm is 3. The difference between them is 1.
Yeah.
Right? So that is why they are asking us to find out such a permutation where actual answer, actual longest increasing subsequence minus algorithm longest increasing subsequence difference should be exactly equal to x.
Yeah.
That is the question.
So this is a constructive question. So there can be many ways to construct this. But let's see one way how we can construct it. For that, let's take n as 5 and let's construct in such a way that whatever satisfies for n5, it satisfies for any n. So now initially our permutation would be in sorted order. If we write, our permutation looks 1, 2, 3, 4, 5. Right? So now what our aim is, let's say LIS is the actual LIS and this is the algorithm's LIS that we are getting. So now in this case, actual LIS is 5, algorithm's LIS is 0, right? So let's maintain this actual LIS as 4 always. And let's try varying
Why
algorithms.
algorithms LIS is 0?
Okay, sorry. Algorithms LIS is also 5 in this case.
Yes.
So let's try maintaining actual LIS as 4 and algorithms LIS. Let's try varying algorithms LIS. Such that we get, let's see how many distinct differences we can get by doing that. So now let's use the last element. Why? Because why we are using last element is with the last element we can stop this algorithmic LIS to increase, right? But LIS we can never stop increasing. So now let's remove this 5 here and add the 5 over here. Then we can see LIS is 4. We are forcing LIS to be 4 always, that is n minus 1 always for any n.
And this LIS
is the actual LIS.
Is the actual LIS, and we can consider 1, 2, 3,
Three and-
4 or 1, 2, 3,
1,
5,
2, 3, 5.
which is actually contributing to LIS.
LIS.
Now, algorithmic LIS will actually choose the first element which is greater than
Which
the
is
previous
greater
element.
than the
So here, first element will be chosen,
1,
second will be chosen,
2 will
third will
be
be chosen,
3,
fifth element 5 will be chosen,
5 will
and
be chosen.
here we will stop.
Yeah, here it won't
Double.
choose any.
Right.
other.
So algorithmic LIS will also give you 4.
4. So here algorithmic LIS is also giving us 4. If you look at the difference, that is 0.
Yes.
So now let's remove this and put 5 over here. Let's just vary 5's position.
Yes.
So now here also we can observe actual LIS is 4. That is 1, 2, 3, 4. This is what will be the actual LIS. And algorithmic LIS will be 1, then it will choose 2, then it will choose 5. Then it can't update it.
Yes.
So it will be 3, which is a difference 1 here.
Yes.
And now let's move 5 further. If 5 comes here, then we can see actual LIS is still 4.
And the
that is 1, 2, 3, and 4.
Yes.
This will be the actual LIS. And algorithmic LIS is it picks 1 and 5, whereas it can't pick any further. So here it is 2. Difference is 2 here. Now in the next case also, let's just move 5 to front. Then it will still be 4. That is 1, 2, 3, 4 is the
actual LIS.
Actual LIS.
Yes.
And algorithmic LIS will be 1. That is, it will only choose 5.
Yes.
So here we got a difference of 3. Now we could see that we could get all the differences from 0 till n minus 2, right? For 5. When n is 5, we got all differences from 0 to n minus 2. Now, my claim is getting a difference of n minus 1 and n for any number except 1 is impossible. So for now let's consider n is greater than 2 or greater than 1, and let's prove why difference n minus 1 and n is not possible. So to get difference n minus 1, only possible way is to have actual LIS value as 5 and algorithmic LIS value as 1, right?
When n value is 5.
Yeah, when n value is 5. For the same case,
Yeah.
when n value is 5, this is what we want. Similarly, considering for any n, it should be n and 1. And we can even have n minus 1 and 0, but this is never achievable. This is never possible because we can't get 0 as the value. At least one element.
We cannot get 0 as our LIS value
LIS
using the algorithm.
Yeah.
Because
So,
algorithm is considering the first element to be part of the longest increasing
part of
subsequence.
the longest increasing subsequence.
So minimum value of longest increasing subsequence using the algorithm
Yeah.
will be 1.
Will be at least.
Will be at least 1. So this case is not possible.
Yeah. So we can ignore this.
Ignore.
Now let's see if this is possible or not. And here this is also not possible. Why? Because for actual LIS to be n, for sure we should take all elements in sorted order. Right?
Yes.
1, 2, 3 in the order only we should pick. If we pick, and there is only one arrangement, that is picking them in order. If we pick in this way, then algorithm will for sure give us answer as n only.
Yes.
Right? So that is why, because there is only unique way to get n, algorithm will also give n. It is impossible to achieve a difference n minus 1.
A difference between actual LIS minus
Algorithmic LIS as n minus 1.
As n minus 1.
So from this we proved n minus 1. Now n is simple to prove. For n, it is just we should get actual LIS as n, and algorithm so value should be 0. Right? But this is never achieved. So that is why n is not possible. So these are the two scenarios. So here if we look at the casework, if x is n minus 1, if firstly if n is greater than 1 and x is n minus 1 or x is n, then it's not possible. In this case, it's minus. Otherwise, we just saw how we can construct. The way we can construct is, let's say n is greater than 1. N is greater than 1 and x is, let's say x is something which is less than n minus 1.
Okay.
So in this scenario, what we can do is we can place elements over here, so on, and then we can place n, and after n we can place n yeah, actually we can instead of looking it at in this way, let's take n5 only. Okay, let's take 5 for now. After with 5, let's derive and then let's do the same thing for greater n. So here, if x is 0, then we should put 5 at. We can either put 5 here or we could put 5 over here. Anywhere it would give us 0. So for now, let's consider we are putting 5. So basically, one element should be after 5.
X is the difference, right?
Yeah, x is the difference. So if x is 0, then 5 should be here. If x is 1, then 5 should be over here. So that means basically 2 elements should come over here. Right? So we can just look at this as we are putting 1, 2. Basically in the front, we'll be putting elements in the range x plus. Okay, if we look over this, let us derive formula. So if we look over this, we are basically putting only one element after n. So that means, can we say this is n is 5? So n minus x would be 4, right? So from n minus x to n minus x minus 1 inclusive, we can put in this part. We can put over here. Right?
Why are we doing n minus x minus 1?
Because 4 is nothing but n minus 1. Similarly, okay, for now let us put this aside and let us do it for x2 also. So now this range would be 1 to n minus x minus 1. Okay, this should be plus 1. Is it? Not n minus x minus. This should be n minus. As we removed n, this is the lower point and this is the higher. And in the front, we'll be putting 1 to n minus x. In between this, we'll be putting n.
When you say back, when you say front,
yeah.
From which back, from which elements back, and from which elements front?
Yeah, this is for the back part. This range is for this part.
I'm not saying this is back or this is front. I'm saying when you say back, there should be some reference back of which you are referring to. There is some point after which you are saying it as back. There is some point before which you are saying it as front. What is that point?
So the point is where we put nth element. So this is our point.
Okay.
So this is the range that is after this element, which belongs to this range.
Okay.
And this is the part which is before the nth element, which refers to this point.
Okay.
Right? So we put these elements in the front of 5. Then we put n. Then we can put this range elements after it. Right? This way we can just formulate for any n and x. So let's just dry run it for n5. Let's dry run it for n is equal to 5 and x is equal to 3. X is equal to 2. So now we are putting 5. So in this case, n minus 2 is, 5 minus 2 is 3. Right?
3.
We put 3 and 4 till n minus 1. And then in the front, we can put 1 to n minus x minus 1, which is 1 and 2. So now if we look over, this is the sequence that we got when the difference is 2, right? When we dry run. So this way we can just put the ranges, fixing n as the middle point, and what range of elements should be kept after it, and what range of elements should be kept before it. And this is how we can derive. So this works for any n and x. And now we were talking about the edge case, right? When n is 1, we saw for n greater than 1, if x is n minus 1 or n, it's not possible. But when n is 1, n minus 1 is possible. That is, we could just put one element. When n is 1, for sure, the sequence that we can put is always unique. That is 1. And for this, the difference is 0.
Basically, the value we get, the length of the longest increasing subsequence when n is 1 is also 1. And the algorithm that they have given us, using that also, if we try to find out length of the longest increasing subsequence, then also it will be getting 1. So the difference between these two values will be 0. In case of n equal to 1.
Yeah. So we can just handle this edge case. If n is 1 and x is equal to 0, in this case we can just print 1. And basically just handle x cases separately. And x is 1, it's a minus 1. Now for rest all which is greater than 1, we can do the same construction, and we can handle the invalid cases as well. Basically, as a summary, if we look over, if x is n minus 1 or n, then it's minus 1. Otherwise, we can just put n over here in the front of n. In the front of n, we can put range of elements from 1 to this one. And in the back, we can put range of elements from n minus x to n minus 1. These ranges are included, and n and b. So this is the summarized part that we are doing. But few people might think how it's taught in that direction, right? So for that, let's see why we thought in that direction. Let's say for any n5, n is equal to 5, or any n. Firstly, we have actual LIS and algos LIS, right? So now here, if we make observation, Algos LIS will stop taking elements once it reaches the maximum element reaches. Basically, once it sees the maximum, right?
Basically, the algorithm that they've given us is actually taking the next greater element and is considering it to be the part of the longest increasing subsequence. Right? So if it finds the largest element of the array somewhere, then the next elements will not be included in your longest increasing subsequence. Right? So now what we are doing over here is, if we write the array in sorted order, 1, 2, 3, 4, 5.
If we write it in sorted order,
then this is the array which has the largest longest increasing subsequence. Right? The actual LIS value over here will be 5.
So actual LIS is 5.
Right. And the algorithm, if we use the algorithm and try to find out the longest increasing subsequence value, it will also be 5.
Yeah, it will also be 5.
Right. The difference over here is 0.
0.
Right. Now we want the other differences also, because x can be 1 also, x can be 2 also, x can be 3 also, and so on and so forth. So what we are thinking is, we'll decide to fix our LIS to a maximum value and make sure that our algorithmic LIS value is reducing every single time. Right? Now, one way to reduce our algorithmic LIS value is to move our largest element backwards. Because if you move your largest element backwards, imagine your 5 is moving between 3 and 4.
So,
right, if 5 moves between 3 and 4, then your actual LIS will have elements from 1, 2, 3, and 4, which will give you a value of 4. Whereas
in this case, it's 4.
4. And algorithm is also 4 because it will take 1, 2, 3, and at 5 it will stop. Right. So this is, in this way we have figured out an arrangement where algorithm difference between the actual LIS and algorithmic LIS is 0. Right. What if we place this 5 between 2 and 3?
So if we place 5 here.
If we place this 5 between 2 and 3, now the actual LIS will again be 4 only, because it will take elements 1, 2, 3, and 4. Whereas algorithmic LIS will first take 1, then it will take 2 because 2 is larger, then it will take 5 because 5 is larger. After that, it will not pick any one element because no element is greater than 5. So algorithmic LIS is 3, and the difference between them is 1. And this is how every single time we are moving 5 backwards and finding out the difference between actual LIS and algorithmic LIS. And that is how in the previous steps we got 0 as a difference, 1 as a difference, 2 as a difference, 3 as a difference. Right? So if we observe this carefully, we are actually having some elements towards left of this maximum element and some elements towards right of this maximum element. And if we write these examples for a few values of n, then we'll be able to conclude with this particular arrangement. This particular arrangement where your maximum element towards your, if maximum element is placed at a particular point, then at the back of maximum element will be the elements from n-6 to n-1. And from at the front of the maximum element, you'll have elements from 1 to n-x-1. And this will give you the difference between the actual LIS and algorithmic LIS to be exactly equal to x. Okay.
So if you look at the time complexity, it is big of n per test case as we are constructing the sequence.